Hey students, we're going to go over the ionic compounds and mole conversion problems in the packet here. Now there's going to be a lot of similarities between what we were doing with molecules and the covalent things and what we're going to do here. Now up until this point, we know that 1 mole is equal to 6.02 times 10 to the 23 atoms if we're talking about an element. We know that 1 mole is equal to 6.02 times 10 to the 23 if we're talking about a covalent molecule. Now in this unit, we know that 1 mole of an ionic compound is going to be equal to 6.02 times 10 to the 23 formula units. All right, so this is the thing that we're going to be changing in this unit. We're changing it to formula units. A formula unit is describing an ionic compound. So when you look at salt, for example, salt is composed of 1 sodium ion and 1 chloride ion. So that one thing, the salt and the chloride, is 1 formula unit. If we're talking about rust, which is Fe2O3, that's composed of 2 iron ions and 3 oxygen ions. And so that whole thing is 1 formula unit, okay? But we're going to use the Avogadro's number the same way that we've been using it all along. I'm going to work one problem in each section here. All of the other problems are worked out in the PowerPoint if you need to check your work after you attempt some of these to refresh your memories, or reach out to me if you need some help on these mole conversions. Okay, so first off, how many moles are equal to 8.271 times 10 to the 22nd formula units of iron 3 chloride? So again, reminder, you always start by writing down your given. 8.271 times 10 to the 22nd. You can abbreviate formula units as FUs. Get yourself a little chuckle. FeCl3. We're going to multiply it by a conversion factor. Now, since we have formula units of iron chloride here, we need formula units of iron 3 chloride down here. And if we have formula units down here, the number that's going to go with that is 6.02 times 10 to the 23. We know that 6.02 times 10 to the 23 formula units is equal to 1 mole. And we're going to make sure we write every step in our work, that we include our units and our symbols in every part of our work here. Since we're looking for moles and we have moles on the top, we're done setting up our problem and we can solve. We will be dividing because 6.02 is in the bottom. So we have 8.271, second E 22, divided by 6.02, second E 23. Our sig figs are, again, based off of our starting value, so we want 4 sig figs in our answer. So we should record our answer as 0.1374 moles of FeCl3. Okay? So you can try number 2 on your own there. Number 3, how many ions of nitrate are in 0.755 moles of zinc nitrate? So we have 0.755 moles. You want to make sure that you write your formulas correctly. All right, so we know that zinc has a set charge of +2 and nitrate is NO3 -1. So when we drop and swap, our formula would be ZnNO3 2. So we're looking for formula units. So the unit that I'm going to put on the bottom is moles because I've got moles over here. So I have to have moles of zinc nitrate down here at the bottom. And the number that I put with moles is always going to be 1. Now, I know that 1 mole is equal to 6.02 times 10 to the 23. So I can put 6.02 times 10 to the 23 up here. But you want to be careful, okay? Don't put ions of nitrate just because you're looking for ions of nitrate. We're still talking about zinc nitrate. So I've got 6.02 times 10 to the 23 formula units of zinc nitrate because that's an ionic compound. That means I need to do one more step since I'm looking for ions of nitrate. And if the zinc nitrate, the ZnNO3 is my formula unit, I can see that for every one of those, so for every 1 formula unit of zinc nitrate I have 2 nitrate ions. So when I calculate then, I'm going to have 0.755. I'm going to multiply it by Avogadro's number because it's in the top. I'm going to multiply it by 2 because I have 2 nitrate ions for every 1 formula unit. I'm going to have 3 sig figs for my answer. So I have 9.09 times 10 to the 23 nitrate ions. Okay. You guys can try number 4 on your own. Molar mass. So with the molar mass, we're going to calculate the molar mass the same way that we were doing molar mass for the covalent molecules, where we find the mass of each atom and we add them all up together. So the important thing with this is that you get your right formulas. So aluminum oxide, aluminum has a +3 charge, and oxide means it's oxygen with a -2 charge. So our formula is Al2O3. So that means we want to take the mass of 2 aluminums, which is 26.98 times 2, and we want to add that to the mass of 3 oxygens, which is 16 times 3. So our mass for aluminum oxide would be 101.96 grams per mole. Okay, lead 4 sulfate. Lead 4, that means that it's Pb4 plus. Sulfate is SO4 -2. When we drop and swap and reduce our charges, our formula would be PbSO4 2. So when we calculate the mass, we're going to take the mass of lead, which is 207.2, plus the mass of 2 sulfurs, which is 32.06 times 2. And we're going to add that to the mass of 8 oxygens, 16 times 8. So our mass should be 399.32 grams per mole. Okay, and that's how you find your molar masses. So down here, when we relate the mole and the mass, we know from the past that 1 mole is going to be equal to the molar mass in grams. And we know that we can find the molar mass on the periodic table. So this number is going to change depending on what substance we have. Okay. So with question number 6, what is the mass of 2.25 moles of calcium nitrate? Calcium is 2 plus, nitrate is NO3 minus 1. So we have 2.25 moles of CaNO3 2. So since we're starting with moles, we know that we have to have moles on the bottom. And the number that goes with moles is always going to be 1. We're looking for the mass, so we need to find the molar mass of calcium nitrate. We're not going to use Avogadro's number this time. So we have 1 calcium, 40.08, plus 2 nitrogens, so 14.01 times 2. And we're going to add that to 6 oxygens, so 6 times 16. So our mass is 164.1 grams of CaNO3 2. So then to solve our problem here, we have 2.25 multiplied by our molar mass, because it's in the top, 164.1. We have 3 sig figs that we're starting with, so we're going to want to round our answer to 3 sig figs, so we should be getting 369 grams of calcium nitrate. All right, and then you guys can try number 7 on your own. And let me scroll up here so we can look at these multi-step problems. What's the mass of 4.2 times 10 to the 24th formula units of ammonium chloride? Ammonium is NH4 plus 1. Chloride means it's just chlorine's ion from the periodic table. So we have 4.2 times 10 to the 24th formula units of NH4Cl. We are going to multiply that by a conversion factor. Since we have formula units here, we know we have to have formula units down here. So whatever unit you're trying to get rid of, that should go at the bottom. The number that goes with formula units is always going to be 6.02 times 10 to the 23rd. And we know that 6.02 times 10 to the 23rd formula units of ammonium chloride is equal to 1 mole of ammonium chloride. But we're not done because we're looking for the mass, and this has moles, so we need to do another step. So since we have moles up here, we need to have moles down here in order to cancel out the mole. And that's 1 mole there. Now we have to find the mass of ammonium chloride. So we have 1 nitrogen plus 4 hydrogens plus 1 chlorine. So our mass is 53.5 grams of ammonium chloride. So in order to solve then, we've got 4.2 second E 24 divided by 6.02 second E 23 because it's in the bottom times 53.5 because it's in the top. We have 2 sig figs to start with, so we need 2 sig figs for our answer. And so we would round our answer to 370 grams of ammonium chloride. Okay. Number 9 here, how many formula units are in 20.00 grams of tin 4 oxide? Tin has a 4+ charge here. Oxide is O minus 2. So we have 20.0 grams of SnO2. So we need to put grams on the bottom. So we have grams of SnO2 down here. That means that we had to find the molar mass. I think that the mass of tin is, I can never remember this one. Let me look. 118.71 plus the mass of 2 oxygens, 16 times 2. So we have 150.71. And we know that the mass of tin oxide is equal to 1 mole of tin oxide. But we're not done setting up our problem because we're looking for formula units, so we need to keep going. Since we have moles up here, we need to put moles down here in order to cancel it out. And 1 always goes with moles. I'm looking for formula units, so now I know I can use my other conversion factor of 6.02 times 10 to the 23 formula units of tin oxide. Okay, and I can take my 20 divided by my mass, 150.71, times by my Avogadro's number, 6.02 times 10 to the 23. And I'm going to have 4 sig figs for my answer because all of those zeros are significant. So my answer would be recorded as 7.989 times 10 to the 22nd formula units of SnO2.